All right, next segment. It's just like programming. It's like that's the equivalent of like missing a semicolon. Oops. Or as actually more of the equivalent of missing a break in a switch statement. So fun. Okay, next up. We have a bunch of inputs. Thank you. Interrupt handler. Read from input 1 through input 4. Write the input number when the value goes from 0 to 1. 2 interrupts will never change in the same input cycle. What? Write the input number when the value goes from 0 to 1. Okay. Oh, okay, I see what it means. So if it's 0 through 1, this is 4. Okay, let's take a look at plot. My sister was over for the holidays. I think to check on me, make sure I haven't gone off the deep end. I know it caused some worry. Her kids saw me working here and suggested I could surf the web for TIS 100 specs. So even kids are on the internet, online, blah, blah, blah. It's a racket. I don't care about the information superhighway, and it never will. Yeah, it just wants to know which input had the change. That's what it is. So we just have the accumulator, but I need to know. Oh, that's fun. It's not how many inputs changed, it's which input changed, right? Because like when this in1 goes from 0 to 1, that's an out 1. When this input 2 goes from 0 to 1, it changes to a 2 out. And so these will never go from 0 to 1 in the same cycle. So we just need to constantly check the previous one that we got and see if it's a 0 or a 1. Yeah, the number of inputs. So like this one is 1, this was 2, this is 3, this is 4, but it's always going to give me 0s or 1 as input. So if we do how do I want to do this? Yeah, only a change from, because we see this one like input 4 here is 0, 0, 1. So that's when we put a 4 in here. And then it's a bunch of 1s back to 0. That's still not the case. And then back to here. So it's only from 0 to 1. So I need to check to see if the previous one was a 0. Okay, so if the previous one, if it's a 0 and the previous one, I could start, okay, so let's, if we start, we know we're all 0s at the very beginning, right? So I want to check to see if you're a 1 now. So move up to ACC. If your jump equal to greater than 0, so if you're 1, ACC should have the previous number, but in order to compare it, I need this, right? I need to move it up into here. So I would need to save it. It's basically a double, it's a double if. It's an if within an if. So if you're greater than 0, that means you're not a 0, so you're a 1. So we're going to check. If we're checking, we also have to now swap with what we had previously and then check to see if you're now a 0. So equal to 0. And then we flagged it. We interrupt. So if we interrupt, we want to move, let's say, 1 down. If we're not interrupt, we have to do something else. We have to jump to somewhere. I guess we move 0. Do I move 0 down, or do I just jump back to start? I don't know. If we interrupt, we move 1 down and then we're done. I could move it down to save it too. That could be other thing, is like we could save it below as well. Oh, if we move 1 down, then I need to we swapped swap and save. Does that make any sense? So whatever ACC is, make it to save. Make it the new save. And then back up to start again. So, okay, here. If we're... Oh, save. So, 0... Oh, I want it to be... If you're checking... Okay, so if you are a... Huh. Input 1, greater than 0. Oh, check. Otherwise, we want to jump to start again. So move up. So then we have that 1, check, swap, so it's a 0. If it was equal to 0, move 1 down. Oh, now you're just waiting for me to do something with this. So then I want to move up, right. Now, if I do this entire thing with everyone, and the only difference is this like moves 2 down, this moves 3 down, this moves 4 down. This sort of is a pain, but okay, so we move you right, which means that you have to handle, at some point in time, we have to handle all of them. They can all be 0s though, which means that we have to have an else. So if you check to see if you're a 1, we either interrupt. Oh, so we have to have an end. We have an else. So an else is going to be a move 0 down. You'll probably have an easier time debugging just the rightmost one. Oh, because it's or even the third row, which is a straight path down. Yeah, we can just debug this one first. Yeah, that makes sense. Okay, so if we move up, down, so we just move these down, so we either get 0 down. And let's just try simple, right? The interrupt will cascade into else. You're right. Move up, down. So I want to jump back to start again. Let's do what you were suggesting though. Where's my mouse? There you are. Let's try just doing this one here. So we're gonna jump, start. So if we run you, so okay, you're 0s. Okay, so then we have 1. Oh, but you crashed before that because you're supposed to be a 4 here. So I can't just debug you. Okay, so 4. Okay, so I need to handle all of them coming together and sort of combine them into so I need to combine them into the one thing. So then I need to move up to down, and I need to move, okay, so move up to the accumulator. Do I don't need to compare them. What if I just add? Because only one of them can change in the same cycle. So what if I just add? So I'm okay, moving up right to here. I then add up, add left, move ACC, sure, down. And then I want to move 0 to ACC. So just reset that. And then we're just going to move up right. We're going to move up to down there like that. We're going to move up to down, move up left. And so I want to add left, add up, add right, move ACC down. Where did I have a missing comma? Move ACC down. Oh. Huh. I wonder, it usually tells you if there's a problem. Like if I did that, I wonder if that's gonna have an issue, or if it doesn't matter at all. And then we want to move 0 to ACC. I wonder if that would just work. Close. I have bad logic. I didn't have all the logic be correct. So let's just okay, so then this is gonna be move 1 down, move 2 down, 3 down, 4 down. What if you run? So this one this one's supposed to be 3. What did I get? I got a 0. So in 3, oh, I need to reset my, so on interrupt, I move 3 down. I don't need to swap, I don't need to swap save. I need to move 0 ACC. And then I save. That worked on the first one? That did not, I don't think. So if I check, okay, so we do an interrupt. Oh, wait, I don't want to. Do I just want to swap again? Oh, so I got a 3 when I was supposed to get 0. So this is if you're greater than 0. Okay, so I want to swap. And then I want to move 1 to ACC. Probably will leave the ACC with the value of the input for that run. Yeah, maybe we just don't do swap. We just jump back to start. Okay, so okay, much better. So then we get to here, and you're supposed to be a 3 now. So you were probably, let's see. If I check and else move 0 to down. Okay, so you were a 1. Right? No, you were a 0. Is this one right here, right? So it's 1 0 1 1. Okay, so I want to check in. Okay, so we have a 1. We have an accumulator for that. So we get 1. Oh, your backup was 0. Your backup was 1 still, so it doesn't know. So I need to interrupt, move 3 down. Whatever the previous one was. So I swap back up to the accumulator. I interrupt, move 3 down. Okay, so if if you're that one, move 3 down. Jump back to start. Swap it back after jump in check. Yeah. If I jump to interrupt, I could swap back there. That doesn't work. Figure code fails with input values other than 1 and 0. Yeah, but our input values are clearly always going to be 1 and 0. So like I don't have to worry about I don't have to worry about that. They're always going to be 1s and 0s. I move 3 down. Almost like, do I want to just save whatever this was? Like instead of swap, I save? No. That's not what I want either. You have 2 branches, jump from checks, maybe swap in each of the branches. Yeah, so we have move up to ACC. So check swaps. And then interrupt. Okay, so we swap. So this became, if this was it was a 0, I want to put it a 1, and then I want to keep it to be whatever it was previously. So I move you down, jump start. Oh, the cat does not let you see all. Yeah. Sorry about that. But Zilby's like that. Cats don't let you see all the inputs. That's the that's how cat debuggers work. So both an interrupt and an else swap it back. Yeah, we could try that. So I could try swap. And now it thinks, okay, so it got when it was previously a 1. If you're an interrupt, I want to, if we're interrupting, we know that it was previously a 0 and now it's a 1. So I need to make sure that our previous one is now a 1. So we want to save you. Do I just want to save instead of swap? No, that's the same problem. And interrupt. Okay, so when we check, we swap to what the previous one is, which does make sense that I want it to be a swap again, doesn't it? But we have the same problem, don't we? So I want the first thing that we do is swap and start. So this is, okay, so in 3, we had a, we had a 1. Okay, so hold on, let's see what's going on here. So in 3, we have our first interrupt. Okay, so we move you up there. We check. We swap. If you're equal to 0, we interrupt. We are equal to 0 now. So we interrupt. I don't want to swap back because we want to keep that our previous one was 0. I need to make sure that you then stay there. If we run you again, much better. So now you're supposed to be, okay, 2. So now let's copy this logic. Say everywhere again. So 1, 2, 4. Hey, it's like a gnat. There we go. It works. All right.